like to turn it over to my colleague, Phil Klotzbach, who's a brilliant young guy, graduated from college at 18. He's been with me 5.5 years. He's now working more with the seasonal forecast than I am, although we meet every day and talk. And it's been a great privilege working with Phil. He's walked the Appalachian Trail all by himself. He's climbed most of the 14,000-foot peaks in Colorado. He's quite a young fellow with a great promise.
Well, thank you very much for that wonderful introduction. Working with Dr. Gray over these past 5.5 years has been amazing. He's taught me just about everything I know about hurricanes and about seasonal prediction. And that's what I'd like to talk with you about is our forecast for 2006, which, as I'm sure you all know, the 2006 hurricane season is very fast approaching. It seems like just yesterday the 2005 season was ending, and now we're on for 2006. The hurricane season starts on June 1st. We're calling for another very active hurricane season in 2006. We're calling for a total of 17 named storms, 9 hurricanes, and 5 major hurricanes, which are the Category 3, 4, and 5 storms on the Saffir-Simpson scale. Our net tropical cyclone activity, which basically is an aggregate measure of how active a season is, these first 6 parameters normalized by their climatological average values. So basically we're talking about twice the average hurricane season that we experienced from 1950 to 2000. And as you can see, both our statistical forecast and our analog forecast are both calling for well above average activity this year. Our statistical forecast uses a total of 6 predictors that span the globe. These are the regions of those 6 predictors. And the combination of these predictors calls for a well above average season. Likewise, we use analog predictors. Basically, the way we come up with our analog years is we look for years in the past that had conditions similar to what we observed since this forecast was issued around the 1st of April. We look for conditions in February, March of 2006. We see what conditions we had in the atmosphere and in the ocean. And then we go back and look for years in the past that had conditions similar to those. And we also look and say, well, we kind of have a rough idea of what we think is likely to be present during the hurricane season, conditions that we're likely to see, say, through August through October period. And then we look for years in the past that had conditions similar to that. And basically, these 4 years are the years that had conditions most similar to what we expect to see in 2006. You can see all 4 of these years are very, very active hurricane seasons. And basically our final forecast of 17 named storms, 9 hurricanes, and 5 major hurricanes is basically right in line with our average of our 4 analog years, lending confidence to our forecast for a very active season. Now, a couple of physical features that currently are present that help encourage us to forecast so much activity this year. First of all, as you can see, the tropical Atlantic is quite warm again this year. It's been very warm since about 1995, when, as Dr. Gray talked about and Mr. Mayfield talked about a couple of days ago, we went to a more positive phase of this Atlantic multi-decadal oscillation, basically more tropical cyclone activity in the Atlantic. Warmer sea surface temperatures basically provide more fuel for developing systems. You tend to have more waves developing into tropical cyclones, less vertical wind shear, basically just a juicier region for tropical cyclone development. Likewise, you also will see in the Pacific Ocean, we had weak La Nina conditions develop during the middle part of the winter and go through the early part of the spring. Now, we've started to trend more towards neutral conditions this year, and we think it's likely that we're going to see neutral conditions in the Pacific this year. And basically, since when you have an active Atlantic multi-decadal oscillation, you tend to have, if you have neutral unsettled conditions and a warm tropical Atlantic, that tends to mean a very active tropical cyclone season. So we're predicting another very active year this year, again, just to reiterate, 17 named storms, 9 hurricanes, and 5 major storms. Now, people always say, well, how accurate are your forecasts? Should we really put any stock in what you have to say? And obviously, you can't say exactly with any great degree of confidence we're going to see exactly 17 named storms this year. I mean, we might see 17, but we could say see 15 or 16 or 18 or 19. But what you can say, even from our early December forecast, which is a full 7 months before the season starts, is whether we expect the season to have above or below average activity. And you can see, using that as our skill metric, we go the right way. That is, we can correctly predict an above or below average season in early December about 75% of the time. And that skill improves. By early April, we go the right way about 85% of the time. And then by early June, we'll put out our next forecast on May 31st. We go the right way nearly all the time. And that's to be expected. As you approach the season, you're better able to see how the atmosphere and how the ocean, how the conditions are forming and how everything's developing, and you develop a more skillful forecast. As I mentioned, our next forecast goes out on May 31st to coincide with the start of the hurricane season on June 1st. And then we actually issue 3 updates during the season where we basically go through any activity that's occurred up to that point, update our seasonal forecast, but mostly we issue these updates on August 3rd, September 1st, and October 3rd to discuss our monthly predictions. We issue individual monthly forecasts for those months of August, September, and October. Our 5 storm, winds of about 115 miles per hour or greater, the really bad ones. The probability this year for the entire U.S. coastline is very high, 81%, compared with the last century average of 52%. Likewise, the East Coast, which includes the Florida Peninsula, 64% compared with the last century average of 31%. The Gulf Coast probability is also quite high, 47% compared with the last century average of 30%. You note that the ratio, it's higher ratio between the two in the East Coast this year, and that's due to the fact that not only is net tropical cyclone activity predicted to be very high, we're also the North Atlantic sea surface temperatures have been very warm the past few years, and therefore likelihood of landfall on the East Coast increases due to that as well. We also expect above average major landfall risk in the Caribbean due to the fact that we expect the tropical Atlantic to be very active this year. Now we're working on, it's going to be hot off the presses when we put out our forecast on May 31st, is a probability forecast using our tropical cyclone activity forecast, but then also taking a look at steering currents. Basically, the steering currents are steering flow in the mid-levels. Now, you obviously can't say months in advance exactly when or where storms are going to strike. We provide probabilities not only for 11 regions, but also for 55 sub-regions with basically groups of several counties that were created based upon coastal population density. And we actually have probabilities down to the county level, basically every county along the U.S. coastline from Brownsville, Texas to Eastport, Maine. We based the original database on data through the 2000 season using the 20th century data. We've recently gone back and updated the database through the 2004 hurricane season. And also, especially along the East Coast, where we had fairly dense coastal populations during the latter part of the 19th century, we've gone back and included some of that data as well. Chris Lancey and others at the Hurricane Center and the Hurricane Research Division have gone back looking into the 19th century and tried to reanalyze the intensities of these tropical cyclones and have a pretty good idea of their intensities at landfall now. So we've included that data where it's been deemed appropriate. So now, for example, let's look at some data that you can obtain from this webpage. This is Region 2, which is the extreme eastern part of Texas and the western part of Louisiana. These 3 regions shaded in green, red, and blue are subregions. Again, these are groups of several counties. And then you can see that we have data for each individual county. And we're going to use Cameron Parish, Louisiana, as our example case for today. So now when you click on the county, you're provided with just some demographic information about the region that it's located in, as well as just some historical data. For example, Region 2 was hit by 20 named storms, 8 hurricanes, and 2 major hurricanes during the 20th century. We also provide probabilities of landfall. The number on the right in parentheses, that's your climatological average probability, so that's based on 20th century data. And then the number to the left is the probability for the current season based upon the latest forecast. This is again for the region level. We provide these probabilities for named storms, hurricanes, as well as intenser the major hurricanes, the category 3, 4, and 5 storms. Likewise, we provide probabilities all the way down to the county level. When you get to the county level, we provide you the probability of receiving 1 minute sustained winds of a particular force. Again, the number on the right is climatology, and the number to the left is the probability for the current year. We also provide vicinity probabilities. Basically, these probabilities are calculated based upon the inherent uncertainty in track and intensity prediction. Say, for example, this is kind of the probability of being inconvenienced by a tropical cyclone in any particular year. Obviously, there's a much larger area, say, in the cone of uncertainty at 5 days that would actually experience, say, major hurricane force winds. But this is kind of, again, the probability of maybe you having to go out and buy plywood or check on ground, make sure she's got enough food and water to get through the storm and that kind of stuff. So that we include those probabilities. And we also include 50-year probabilities. 50-year probabilities are based on the idea that for any one year, for any one county, your probability of being hit by a storm is fairly small.